Now, as it happens, this morning our first speakers were not content to simply be engaged. They went ahead and got married. And I would like to begin their introduction with a story about Los Angeles and food. Later this year, national legislation will require chain restaurants to display calorie counts on their menus. And here in Los Angeles, such labeling has been in place for about a year now. And the intent of this new law is clear: to combat the country's growing obesity epidemic, especially among children. The expectation is also clear: that better informed consumers equipped with this knowledge will make healthier food choices for themselves and for their families. So that barbecue chicken salad at California Pizza Kitchen might be delicious, but with 1,100 calories and 18 grams of saturated fat, perhaps it doesn't sound quite so healthy. Last year, however, researchers at NYU made an interesting discovery, a disheartening discovery. There has been no significant change in the number of calories consumed since labeling began. And worse, there's been no change in the number of calories for choices parents have made for their children. So what accounts for this result? And why did we expect to find something different? The answers, I would suggest, lie in the fields of consumer and social psychology and decision making. And Penn is lucky enough to have not one, but two of the world's leading experts in these disciplines. So this morning at Engaging Minds, I tell you, you're getting a 2-for-1 deal. They're both with us this morning. Professor Barbara Mellers studies how people formulate preferences and arrive at their choices. Her extensive and globally influential research focuses on decisions that deviate from rational principles due to concerns about fairness, past mistakes, and emotions. At Penn, she is I. George Heyman University Professor with appointments in the Department of Psychology in our School of Arts and Sciences and in the Department of Marketing in the Wharton School. Professor Philip Tetlock is also world-renowned as a scholar of decision-making. Among other things, he has argued that so-called expert predictions are no more reliable than those made by non-experts. Research that has angered just a few experts in the process. Currently, he studies organizational decision-making. At Penn, he is Lenore Annenberg University Professor with appointments in the Department of Psychology in our School of Arts and Sciences and in the Department of Management in the Wharton School. So it's my great pleasure to introduce this morning Professor Barbara Mellers and Professor Phil Tetlock.
Thank you very much, Amy and Vince, for that wonderful, wonderful introduction. I'm going to explain what IARPA is. I'm going to explain what these four rather goofy-looking creatures are. And I'm going to explain what we're doing involved with them, because we're also lined up getting ready to throw at the dartboard. In fact, Barb and I are, as part of our work with IARPA, coordinating a team of about 2,500 forecasters from around the world who are testing their wits, trying to assign realistic probabilities to a wide range of events, from what's going to happen to the Eurozone, to the stability of the North Korean regime, to the situation in the Persian Gulf. So just a really wide range of questions and a really wide range of participants. Now, IARPA, Intelligence Advanced Research Projects Agency, is one of many alphabet soup government agencies, federal government agencies in Washington, D.C. It's embedded within another alphabet soup super agency known as the Office of the Director of National Intelligence. And that office was created in response to the Presidential Commission after the events of 9/11 to remedy what was seen as one of the major defects in intelligence analysis at the time, which was the quote-unquote failure to connect the dots. Yeah, we'll revisit that phrase shortly. Now, what do these four creatures represent? Each of them represents a distinct philosophical perspective on forecasting. The chimp symbolizes surrender to what statisticians call the stochastic. Eat humble pie, admit you can't do better than chance. In other words, you may pay a lot of money for fancy investment advice, but the fancy investment advisors may be hard-pressed to do better than you could do by simply putting your money in a low transaction cost mutual fund that mimics market averages. The fox and the hedgehog are a little more mysterious. They symbolize clashing approaches, clashing perspectives on how to do better. The fox and the hedgehog metaphor comes from a poem by the ancient Greek warrior poet Archilochus, a fragment of whose work survived. And one fragment read, "The fox knows many things, but the hedgehog knows one big thing." And foxes are more likely to take an eclectic, flexible approach and avoid any commitment to any ideological or theoretical point of view. But hedgehogs are more likely to look for simple keys that allow them to explain a lot with a little. So in some sense, hedgehogs are very ambitious scientific theorists, but they're often a little too heavy-handed in how they apply theoretical and ideological generalizations, and that can get them into trouble. So the hedgehog knows one big thing, exudes confidence that it has the theoretical keys to nature. The fox knows many things and is adept at exploiting the overconfidence of hedgehogs and their blind spots. And then finally, there's the symbolism of the black swan, which comes from Nassim's recent popular book on radical unpredictability in the world. From Nassim Taleb's perspective, we often don't know what we don't know. And we might even be aiming at the wrong dartboard. There's a great deal of mystery in life, and the best laid plans of forecasters are often devastated by events that just weren't even remotely on their radar screen. Now, which approach is likely to work better in which types of problem domains? I've laid out on this slide a predictability continuum. At one end of the continuum, you have the extremely predictable. At the other end of the continuum, you have the completely unpredictable. So nobody's able, if you know whether the roulette wheel landed on red, white, or black, red, green, or black on any given spin, it gives you absolutely no knowledge whatsoever about what it's going to land on the next time. In short, it's impossible to do better than the chimp when you're looking at the roulette wheel. At the other end of the continuum, you have a completely deterministic system that's very well understood by physics, Foucault's pendulum. So some very simple scientific laws of the sort that appeal to hedgehogs, because hedgehogs like to explain a lot with a little, and they're looking for powerful generalizations. If you have a problem that is a Foucault's pendulum type of problem, this is where the hedgehogs are going to do best. And then there's a vast range of problems in the middle that are neither completely predictable nor completely unpredictable. And I use the illustration of a hurricane, which has some elements of predictability and some elements of unpredictability. And one of the things we're discovering in the course of our data analysis is that many things in the political and economic world are hurricane-like, in the sense that they have some elements of predictability, some elements of unpredictability. Now, one thing that you need to come to grips with if you're going to understand forecasting is that there is, for most forecasting problems to the right of Foucault's pendulum, there is, for those problems, an irreducible element of uncertainty and unpredictability. And that means that mistakes are inevitable. And if mistakes are inevitable, that means that society has to make some difficult judgment calls. Society has to make judgment calls about which mistake is it worse to make. Is it worse to make the mistake of a false positive judgment, which in the intelligence community might take the form of overconnecting the dots and claiming that there are weapons of mass destruction when there are not? or the mistake of a false negative and underconnecting the dots, which was the original critique of the intelligence community that led to the formation of the agency, that led to the formation of the sub-agency, that led to this project. Underconnecting the dots. And that, of course, is the devastation of 9/11. Then there are these interesting judgment calls in the middle, like the successful Navy SEAL operation against Osama bin Laden last year. It's generally agreed that the intelligence community was not able to give President Obama an exact 100% answer, 100% confidence conclusion that Osama is in the particular location in Pakistan where he was. It's fact, I don't think the intelligence agencies were able to give him much more than a 50-50 estimate. So it was an inherently difficult judgment that he had to make. If it was a 50-50 judgment call, it's very easy to imagine that he could have sent those Navy SEALs into a city inside Pakistan. They could have stormed through a house, killed innocent people, and it would have been a massive diplomatic uproar. And rather than being acclaimed for being a decisive and strong decision maker, he would be denounced as reckless and foolish. And what does this illustrate? Well, it illustrates something very interesting about life and about politics and about forecasting, and that is there is a very fine line in history between spectacularly good judgment, a reputation for having spectacularly good judgment, and a reputation for having spectacularly bad judgment. Now, the intelligence community is accustomed to being whipsawed by conflicting critiques from various political factions. Of course, they were condemned very sharply for underconnecting the dots after 9/11. Some people believe they overcompensated by overconnecting the dots for weapons of mass destruction in Iraq, partly because they had made the other error. Some pessimists argue that's pretty much as good as it's ever going to get, that we're fated to be continually whipsawed between conflicting critiques. You overconnected dots, you underconnected the dots, and they're simply going to go back and forth. One of the major conceptual rationales for this project is an attempt to escape what is sometimes called accountability ping pong. Accountability ping pong is a game in which the intelligence agency plays the ball and it's bashed back and forth continually for either making a false positive or a false negative judgment. So it's an effort, this forecasting exercise is an effort to put the debate on a higher scientific level and to escape endless cycles of accountability ping pong. It's an effort to escape decades of hindsight-informed second-guessing, because once you know the outcome, it's really obvious. It's really obvious that Obama should have made the decision he did after the fact, but it wasn't at all obvious before the fact that he should have. And the solution that, another aspect of this that IARPA is trying to escape is the intelligence community spends hundreds of millions of dollars of your hard-earned taxpayer money on products that promise to improve forecasting accuracy but are never tested, never systematically tested. So this is an effort to subject these techniques to systematic testing, and the solution is to commission a level playing field tournament that pits dozens of approaches against each other on hundreds of questions over many years. Because you need to do something on a big scale if you're going to get a reasonable scientific answer to a question that is of this scope. Now, I'm going to give you a few examples of the types of forecasting problems that we've been giving our forecasters. Each of the lines you see on this graph here represents a distillation, a statistical distillation of the best forecasters we have right now in our forecasting tournament. Their best guesses for how likely it is that, that the euro will fall below $1.20 sometime in 2013. And you can see that the best probabilistic estimates of our best forecasters range between about 0.7 and about 0.99 on that. I think the euro right now is worth about $1.30. Here is the range of estimates that our forecasters are assigning to Brent crude oil, going above $150 before April 3rd. And you will notice that at the gas station if it does. Probabilities between about 0 and 0.3. Here's a fellow, Mario Monti, who's an economist and a technocrat who recently became Prime Minister of Italy after the flamboyant Silvio Berlusconi. And he is widely regarded as the last hope for keeping Italy in the Eurozone. So whether he will stay in office up through January 2013. And here the probabilities range from about 0.3 to about 0.7. Here's a situation in North Korea where you have the best informed judgments really take a spectacular range of values from about a little less than 0.1 to about a little higher than 0.5, sometimes up to 0.6. And here you have a situation that everyone knows is very ominous. That is the issue of whether or not Israel or the United States or some combination of countries would launch a preemptive strike against Iranian nuclear facilities, probabilities ranging from about 0.1 to about 0.6. Now these aren't necessarily the right answers, but based on the forecasts that we've analyzed so far, they provide our best scientific guesses for generating realistic probability estimates. This is a rather expensive project, but it is extremely inexpensive compared to the cost of the wide range of intellectual strategies that are used within the intelligence community to generate these. And the interesting thing is that IARPA is willing to fund research that has the potential to reveal that it could accomplish its the intelligence community could accomplish its key missions far less expensively than they can right now. So it's an unusually politically courageous thing to do, in my opinion. So those are examples of the forecasting problems, and now I'm going to introduce my wife Barb, who's going to talk about some other aspects of our IARPA project.
Thank you very much. It's a pleasure and an honor to be here and have an opportunity to tell you about our research. Let's see here. I have been studying decision making for the last 30 years, and I've studied the whens and whys and wheres of various mistakes we make. This is the best opportunity I've had to study how we can do things better, how we can make better judgments in the domain of forecasting. So this is just a real treat. And I'm delighted to tell you a little bit about it. Now, it's a tournament in the sense that IARPA has funded 5 different teams of researchers all over the country to come up with the best possible ways of identifying forecasters. Actually, this is identifying good forecasters in different domains, and then coming up with ways of asking questions, eliciting forecasts, and combining them to arrive at the best possible prediction. I'll tell you a little bit more about what we're doing in just a moment, but the project is about 9 months out. We're into our first year. With luck, this will go for 4 years. So we'll have a chance to tweak it and keep improving on what we find that works best each year. Our team, you'll be happy to know that Team Penn is currently in first place. As Phil mentioned, we've recruited about 2,500, 3,000 forecasters all over the country who interact with us via the internet and make predictions on a continuous basis. There's a period of time that a question is open, and they can update their forecast throughout that window. You saw some of those questions. Now, all forecasters need a BA or higher, and they must be US citizens. We will be looking for forecasters in year 2, and I'll come back to that in a little bit later. Okay, now, as I said, these are 2 of our big goals. Let's start with the first one, identifying good forecasters. How do you identify a good forecaster? Well, it's not easy. The very best way to distinguish experts from pseudo-experts is to keep score, to track the accuracy of many judgments over extended periods of time. Now, obviously, this is non-trivial. It's extremely difficult to do this in business, in the law, in medicine. But in many circles, one way of keeping track of good forecasts is to use something called Brier scores. And let me give you an example of how Brier scores work in the case of weather forecasting, and I'm going to tell you in just a moment about a hypothetical weather forecaster whose job it is to predict rain. Okay, so Brier scores are pretty simple. They range from 0, 0's the best, to 2, which is the worst. We have a forecaster here who says on day 1, there's a 90% chance of rain, and it rains. So the Brier score is essentially the squared deviation between what happens, rain, and the forecaster's prediction about what would happen. That's squared. Then we take what didn't happen and the forecast for what didn't happen. This is a good forecast. The Brier score for this is 0.02. Again, 0's the best. A chimpanzee who was just guessing would have a Brier score of 0.5. We keep going. We keep doing this. Day 2, he says there's a 20% chance of rain. It doesn't rain. That's pretty good. Brier score of 0.08. Day 3, 60% chance of rain. It rains. A little bit worse. And on day 4, he predicts a 70% chance of rain. It doesn't rain. His Brier score goes up to 0.98. Okay? Now, for this particular individual, the average Brier score is 0.35. So he's got some knowledge. He certainly has a lot of room for improvement, better than the chimpanzee, but certainly not down there at 0. The average, the base rate for rain, this is not LA, in this particular case, is 50%. His average forecast is 60%. So there's 2 elements of good forecasting that I want to illustrate here. One is the ability to discriminate signals from noise. Have high numbers on days when it rains and low numbers on days when it doesn't rain. A second very important ability is to be well calibrated. That is to say, over a long period of time, your average forecast equals the average rate at which that event occurs. This is known as calibration. And it, just as discrimination is very difficult, calibration is also very difficult. And just to show you how difficult it can be, I'm going to do a little demonstration with you right now. So you have at your table pen and paper, and it's for this particular demonstration. So take the pen and paper, and here's what we'll do. I'll be asking you about 10 Trivial Pursuit, general knowledge questions. Now, I'm not going to ask you to write down the right answer, although you might want to if you'd like. What I'd like you to do is to give me a range, a 90% confidence interval. I want you to set boundaries such that you're 90% sure the correct answer falls within your interval, okay? And if you're well calibrated, then 9 out of 10 times, the correct answer should fall within your intervals, okay? So we'll go through the questions first. You establish your upper and lower bounds. Then we'll go back through them again. I'll give you the correct answers. And you score yourself according to yes, no, did I get the correct answer in that bound or not? Okay? All right, let's go ahead. First question. What is the time elapsed since the Big Bang? Okay? Write down your lower bound and your upper bound for your estimates of this time period. We okay? I'll move ahead. Next question. The year that John Steinbeck won the Nobel Prize for Literature. Lower bound and upper bound? Third question, the distance in miles from the Earth to the moon. Give me your 90% confidence interval. Number 4, air distance in miles from Madrid to Baghdad. Number 5, the year the construction of the Roman Colosseum was completed. Never was. Okay, we can talk about that, sure. Number 6, the year that Magellan's crew completed the first naval circumnavigation of the globe. Lower bound and upper bound. Number 7, the height in feet of the Aswan High Dam. I know you've just got that at your fingertips, right? Oops, sorry about that. Number 8, the year that Mohandas Gandhi was born. I'm going to be asking you guys down here, when this is all over, how many you got correct, huh? Number 9, the surface area in square miles of the Mediterranean Sea. Also at your fingertips, I'm sure. And last but not least, the gestation period of the great blue whale in days. Okay, is everybody ready? Now I'll go through each of the questions again with you, and I want you to score yourself. Count up the number of times the correct answer falls within your interval. Okay? Time elapsed since the Big Bang, 13.8 billion years. Year that John Steinbeck won the Nobel Prize for Literature was 1962. The distance in miles from Earth to the moon is 238,850 miles. The air distance in miles from Madrid to Baghdad is 2,700 miles. And the year the construction of the Roman Colosseum was completed, 80 AD. At least some argue it's 80 AD. The year that Magellan's crew completed the first naval circumnavigation of the globe was 1522. The height of the Aswan High Dam is 375 feet. The year that Mohandas Gandhi was born is 1869. Number 9, the surface area of the Mediterranean Sea is 970,000 square miles. Last one, the gestation period of the great blue whale in days is 335 days long. Okay, now let's see how you did. And I want to tell you how to interpret your scores. If you got 9 out of 10 correct answers that fell inside your interval, you are well calibrated. You know what you know, and you know what you don't know. If fewer fell into the interval, then you're a bit overconfident. You believe you know more than you actually know. You should push out your confidence intervals further to express your uncertainty. Okay, so let's see how things worked. How many of you got 10 of them inside the confidence intervals that you established? Okay, how many got 9 inside your confidence intervals? 8. Looking for 8s. There's a few. 7. We have some 7s. 6. Okay, 6s. 5. Okay, 4. 3. 2. And I won't go any further. Very good. This is very difficult. All right, I've done the same thing. I completely understand. Penn graduates do the same kind of thing as well. Now, we're looking for forecasters. One factor, the reason I'm telling you this is some of the components of good forecasting that we're looking for are things like this: good calibration, good discrimination, and so we're testing our forecasters along the lines of this kind of thing to help us decide to whom we should give a higher weight relative to others. Okay, a few more quick thoughts about what we're doing. We're looking for methods of combining forecasts to obtain the most accurate predictions. And unless there's someone out there who really knows the truth, which would be wonderful, we want to have several predictions. We want many forecasters making predictions of the future. Why? Why do we want many people? Well, the answer has to do with the power of aggregation. This notion is nicely captured in a book by James Surowiecki called The Wisdom of Crowds, which is fun reading. I highly recommend it. Surowiecki tells a story about Francis Galton, the cousin of Charles Darwin, who was wealthy enough to support himself to do anything he wanted. And he did a variety of different things. He was extremely interested in measuring everything out there. There's a story about him going to a livestock fair in 1906, and he stumbled upon a contest. There was an ox on display, and the villagers were invited to guess the animal's weight. There were 787 guesses that were made, and after the contest, Galton collected all of these estimates, all these forecasts. Now, there were lots of different forecasts: farmers, butchers, shopkeepers, and so forth. Lots of people with different perspectives. He computed the average of these forecasts, and he got a number which was 1,197 pounds. Well, it turns out that the weight of the ox was 1,198 pounds. And this idea illustrates the notion that when we average across independent errors, maybe we can reduce that error and come up with a more accurate forecast. That's what we're doing too. We're crowdsourcing, essentially, and looking for wisdom in the crowds. And there's different ways that you can do this. Standard ways of doing it are opinion polls, Gallup, Harris, and so forth. And opinion polls are typically done such that individuals are independent. They need not be. And one of the things we're doing is looking at the effectiveness of individuals who work on their own, individuals who work with information about other forecasters, and actually even individuals who work in small teams, together, teams of 20, and they talk to each other. it's not obvious how to elicit the greatest wisdom from crowds. There's work in psychology on the Delphi method as a reasonably interesting and successful way of group decision making. So perhaps independence, perhaps not. We're also looking at prediction markets, and they're proving hard to beat. Of course, you probably know, the Hollywood Stock Exchange is one of them. It predicts movie successes, box office successes, first weekend. There's also the Iowa election market that predicts political elections. And there's one known as InTrade that predicts a variety of things. I looked at InTrade a couple of days ago to get the price of shares that Romney would be the Republican presidential nominee, okay? This is not Florida, this is the whole shebang, the Republican nominee. Shares are selling for Romney to the tune of 83 cents on the dollar. What that means is you can buy shares in Romney, and if he wins, if he is the Republican presidential nominee, you get $1 back for every one of your shares. All right. So basically, you're putting your money where your mouth is, and there are a number of interesting features of prediction markets that make them really interesting. We're betting on some kind of combination of prediction markets and teams, if we had to put our money anywhere, turning out to be the best of the various techniques that you saw earlier in Phil's slides. I've run out of time. I want to wrap up and finish with an invitation. We would be delighted and honored to have you join us on this project. We are looking for forecasters for year 2, which will begin in June of 2012. And if you're interested in this, go check this website out, www.goodjudgment.info, and we'd love to have you participate and continue to beat the other 4 teams, okay? So thank you very much.